Now let's look at adding and subtracting complex numbers. So if we have the complex number a, which is 2 plus 3i, and b is equal to 3 plus 4i, in order to add a plus b, we add the real part to the real part and the imaginary part to the imaginary part. So we're going to have the 2 plus 3 and the 3 plus 4. So this is going to give us 5 plus 7i. Now in order to subtract, again we subtract the real and subtract the imaginary. So we're going to have for b minus a, we'll have 3 minus 2 and 4 minus 3. So that's going to give us 1 plus I. So that's quite straightforward, and in fact we have already covered that whenever we looked at vector addition and subtraction. So let's go ahead and we will see this in our assembly language. Let's look at the example we have here. On the right hand side we have the calling function, on the left hand side we have the subroutine. So in the calling function we have a complex number which I've called complex underscore a, and it's the number 2 plus 3i. And we've got the complex underscore b, which is 3 plus 5i, and the summation of these will be placed in the answer, which is called complex underscore c, and we've set aside 2 memory locations. So the answer to this should be the 2 plus 3, which is 5, and the 5 plus 3, which is 8. So it should be 5 plus 8i. So we push the address of complex number a, complex number b, and complex number c. We then jump to the addition subroutine. So it goes through the addition, and after it has added, it returns the results to complex underscore c, and that's the end of the program. So let's talk through the actual program. We take the values in the registers, we save them to memory, we pop the return address, and then we pop off the complex C, complex B, and then complex A into registers R4, R3, and R2. We then work out the real part, so we load the value of the real part into register R0. We load the value of the real part for the complex B into register R1. We add R0 and R1, so this will give us the real term plus the real term. So in effect it's just the 2 plus the 3, which is a value of 5. And then we place this into the memory location, which is complex number C. We then do the same with the imaginary part, but to get to the imaginary part we have to increment register R4 and register R3. So we're incrementing the complex A and complex B in order to get to the next value. So this will take us to the value of 3 and the value of 5, but we've also got to increment the register R2 because it gives us the second position for the output, which is the imaginary position. We then go ahead again and we load the values into register R0 and R1, we add them together, and then we store the result in this memory location. And then we go back and we retrieve all of the register values, and that's us finished with the addition. Now in order to perform the subtraction we use exactly the same code, but instead of using this add line here, so add R0 R1, and there's the add R0 R1 here, we simply replace that with sub R0 R1 and sub R0 R1. So I won't bother showing you the subtraction because it's so similar to the addition. Let's go ahead and we will see this in the actual CPU. I have loaded the program into the RAM and the subroutine into the ROM, so let's run this now. And it should run through relatively quickly. It'll pick out the real term and it will add them, and then it will pick out the complex terms and it will add them together, and that's it, saved it, and the program is finished. So we'll stop this and we will go in and look at the results. So we head down to line 500. You see we've got the original value for complex number A, 2 plus 3i, and then complex number b, 3 plus 5i, and then the summation, which is 2 plus 3, which is 5, and the 3 plus 5, which is 8i. So that's 5 plus 8i, and that's the summation. So the same would happen if we were doing the subtraction, except we would subtract the terms off. So that's quite straightforward. Let's move on in the next video, and we will look at multiplication of complex numbers. Thank you for listening. I'll get you in the next video. Goodbye.